We've got somebody's mic on.
Yes, sir. Thank you for everyone for joining us. If you've got your mics on, I would like to request for you to mute them so that we don't disturb any of our panelists or our moderator when they are carrying out the webinar. Please mute your mics. Thank you.
Abbas, good to go?
Yes, sir. People will continue to join in the next 10-15 minutes. That's how it usually happens. So the number of participants will keep on increasing. We've already around 60 participants have logged on, and they'll continue to do so as we go along. I just want to make a couple of quick announcements, and then we can start, sir. First of all, I'd like to thank everyone who's joining us today. I would like to begin by introducing myself. I'm Abbas Jafar, and I'm the Communications Manager for the Institute for Global Health and Development, AKU University. It is my pleasure to welcome you to the IGHD webinar on nutrition, food security, and sustainable agriculture. The IGHD webinar aims to offer participants an opportunity to both gain knowledge and actively engage in the ongoing discourse surrounding the imperative of universal access to nutrition, food security, and sustainable agriculture in the face of pressing global challenges. Please note that the session is being recorded and will be available on our website within a week. I will paste the link for our website in the chat. Before we start, I would like to request the attendees to keep their microphones muted so there are no unforeseen disturbances during the presentations. To facilitate your engagement, we have also enabled the chat for conversations, introductions, and the QA functionality for asking our distinguished panelists questions at the end of the presentations. Please note, when the QA function is enabled, the chat function will be disabled, and the chat function will also be disabled during the presentations themselves. Now let me introduce to you our esteemed host and moderator, Dr. Zulfikar Bhutta. Dr. Bhutta is a renowned academic figure and global health expert, serving as a distinguished university professor and the founding director of the Institute for Global Health and Development and the Center of Excellence in Women and Child Health at Al-Khan University. Dr. Bhutta, over to you, sir.
Well, thank you very much, Abbas, for kicking us off. And I'm most grateful to our distinguished panel for giving us the time to put this webinar together. As you know, the Institute for Global Health and Development has been striving since its inception about 2 years ago to bring the issue of climate change, agriculture, sustainable food systems, and human nutrition to the fore, in addition to many other things that we do. And this is particularly timely because just over the last 2 weeks, we've had an extraordinary session, a series of events in Pakistan on climate, environment, health, and development. And this now caps it right after COP28 with this particularly focused webinar. We have 3 distinguished speakers, and I will introduce them individually as we go along. We have Mr. Apurva Oza, who will talk about sustainable agricultural practices in rural India, followed by Dr. Eric Boy, who has joined us at this early hour from Ottawa, and Eric will be speaking on biofortification. And then Dr. Emmanuel Saleh, our rising star in sustainable agriculture from the Al-Khan University in Tanzania, will be speaking on issues of a living environment lab. And I'm particularly grateful today for the presence in our webinar of one of the most distinguished scientists in agriculture and related issues, Dr. Kausar Abdullah Malik, who is also the current Federal Minister for agriculture in the government of Pakistan and a distinguished academic at the Foreign Christian University in Lahore. And he will be participating and giving us closing remarks at the end of this webinar after we have had the presentations. So without further ado, let me introduce our first speaker. Apurva Oza is a seasoned engineer and a global program lead in agriculture and climate change at the Aga Khan Foundation. He brings a wealth of experience in rural development and has had a distinguished career serving as the Chief Executive Officer of Aga Khan Rural Support Program in India. He has played a pivotal role in sustainable development initiatives, and we're very privileged to have him today to talk a little bit about his deep insights and experiences in addressing critical global challenges in agriculture and climate change. So, Apurva, the floor is yours to take us through your thoughts on sustainable agriculture practices in rural India, please.
I just wanted to check, Sophie, how much time would I have, roughly?
I think it's we've allocated about 15 to 20 minutes per speaker.
Perfect. Let me go then. Let me just share my presentation. I just wanted to check. Can you see my presentation? Is it visible?
Yes, it is, sir.
Okay. Thank you. Let me start off by talking about India and the complexity of working on agriculture in a country like India. As you know, it's a very large country and with very diverse contexts. And so we, AKF and AKRSP, we work in very diverse contexts. One is the coastal Gujarat, there is rain-fed Madhya Pradesh, there is the irrigated and very dense river plains of Uttar Pradesh and Bihar, which are among the poorest states in the country and also among the largest states. UP, if it was an independent country, would be, I think, the 7th or 8th largest country in the world. It's a very populous country, a populous state. And of course, the very semi-arid desert type regions of Gujarat. So this is the various context in which we work. And the bulk of the farmers, as in Asia, in India also, about 85% of the farmers are about small and marginal farmers, very low land holdings. And with every passing generation, the land holding is getting smaller as land gets divided. Fertilizer use in India is quite substantial. It's about 150 kilos per hectare. It varies a lot. So you have Punjab, which is about almost 10 times this number, about 1,000, 1,200 kilos per hectare. You will have very tribal rain-fed areas which hardly use about 40, 50 kilos per hectare. So you have a wide range of chemical fertilizer use in the country, also related to the amount of irrigation available in that particular part of the country. But what is therefore very noticeable and therefore a measure of great concern is that the soil organic carbon content, which is a key, to me, one of the key indicators of the health of the soil, has come down substantially over these last 70 years since we've been independent. So it's come down from about 1% to 0.3%. Now, as any soil scientist or agriculturist tell you, 0.3 is not a good carbon content to have. It hardly enables the soil to have any nutrition or process any nutrition of its own. Most of the earthworms are dead by the time you reach this kind of carbon content. So it's a very poor soil carbon content, right? Organic carbon content. And irrigated area varies substantially from about 10% to 60%. We have in India, we have two implementing agencies. It's a vast country. So we have the Aga Khan Foundation doing direct implementation in the state of Uttar Pradesh and partly Bihar. And in AKRSP is the older institution which works in Gujarat, Maharashtra, Madhya Pradesh, and parts of Bihar. So these are some of the largest states in India, and therefore lessons learned from here are relatively valid for the whole of India and parts of Asia. Now, what are the challenges which we farmers face? They were not very different, but let's say in India, one is that we are seeing even in places like Punjab and Haryana, which were the grain bowls of the country, yields have been stagnating, right? And despite incremental fertilizer use and pesticide use, Punjab has the highest fertilizer consumption in the country, the highest pesticide consumption in the country. The yields have been stagnant, and the costs have been rising. So the real incomes of the farmers have actually been stagnant or been declining. So farming is becoming a relatively less favorable occupation for everybody. With this, you have very poor soil health, as I've already mentioned. Inputs are high, and what happens is that this puts farmers into indebtedness because most of the farmers, they've exhausted the money by the time the next kharif comes in. They need to buy inputs, and they go into debt. So this debt cycle keeps on continuing. The other issues, of course, soil moisture and irrigation availability is relatively low. And with increasing prices of diesel, wherever there is no electricity, the cost of pumping groundwater is becoming higher. So that again adds to the input cost. It also makes it very unreliable because groundwater then becomes very unreliable. And the water quality is also affected. Markets, of course, in agriculture markets in Asia are always an issue, and the value chains are not well developed, except in milk, where India has a very excellent value chain through the cooperatives, but other crops, it's not so. We are noticing there have been a lot of research work done on pesticide use and how it is affecting the health of everybody. In fact, Punjab, which has very high pesticide use, also has one of the highest incidences of cancer in the country. And in fact, there are lots of documents. There is a whole train which is supposed to go from Punjab to another place, to Ajmer, largely carrying cancer patients because there is better treatment there. So the health costs of pesticides are now well documented in this country. Malnutrition is also fairly high in parts of this country, especially Uttar Pradesh and Bihar. So while the food distribution scheme of the government of India has made sure that there is very little food insecurity, but nutrition insecurity is really high, and our malnutrition rates are at a fairly high, among the highest anywhere in the world. So how do you, when we sustain agriculture, what do we mean? So for us, to me, the critical issue now has become is that how do you sustain the soil health? Because without soil, you're not going to have anything else. So soil health is a key. Of course, then you need water, then you need energy for pumping the water. Then you need to make sure that the farmers are healthy and everybody else. So the nutrition availability from the what is grown and also what the quality of the food which is grown. But farming is not isolated. Farming belongs to a larger landscape of the village and the common lands, etc. So unless the landscape is addressed and the issues of the landscape are addressed, you will not have. So for example, if there are no trees in the catchment areas, then there'll be so much erosion that water harvesting structures will be silted, and therefore you won't have irrigation. So the landscape is very important to make agriculture sustainable. Livestock is, of course, a key part of the economy, and sustaining livestock, pasture lands, etc. And finally, you will have the farm economy. How do you, because unless farmers like being farmers, the next generation is going to get out of farming and you're going to have issues. Either agriculture as a sector will become a problem. So you have to make sure that the farm economy, the farmer's voice, which is very critical, and in this modern era, it is increasingly less heard. So how do you make sure that their voice is heard? And do you have enabling policies and programs for that? So this is the challenges which we have. This is largely that, yes, now we decided as an organization and many organizations that how do we need to get away from this high chemical use, high tillage, high fossil fuel agriculture, because it's causing a lot of these problems which are well documented. But when you want to transit with the farmers and the farmers' land is less, then they are very reluctant to take on new ideas. They're very nervous. I put less fertilizer. What will happen to my productivity? Why should I change? So the farmers are reluctant to risk that. So we've realized that first of all, this transition has to be gradual and phased. Some of the transition is very win-win. So for example, replacing diesel engine with solar, it's a great winner. It's spreading very fast. We've not had any problem. It's a win-win situation because the operational cost for the farmers go down. So it's good. It's clean energy, and the farmers save money because they save on diesel costs. So everybody's happy. So it's a win-win situation. But when you say reduce the chemical inputs or the pesticides or fertilizers, then 2-3 years the yields do decline, especially in cash crops. So then the farmers say, oh, well, I'm losing, why should I move into this transition, right? So then there is the whole extension, education, and other ways of motivating farmers to transit, because they know that over a period of time the soil is better, there is less water requirement, and the yields come back. And therefore, it is what I call the win-lose-win scenario. And that is the major strategy we are following in regenerative agriculture. So we combine win-win strategies with win-lose-win strategies to make sure that the farmers then transit to a more sustainable form of agriculture. I'll just start talking about the key issue for us, which is right now the soil, because that is the key. Okay, coming back is that this transition, again, like I mentioned, is hard because of all these factors, including lack of measurement of improved soil health. We only measure NPK. Uh, there are risks, and nobody is bearing the cost of these risks there. So that is there, and you don't even get much better prices for doing natural farming, because markets are not responding very much to this thing. So the soil part which I was talking about is that there is so far historically, and all of us who study agriculture know that the focus has been on soil nutrients and soil productivity capacity. So while we are saying that has not led us very far, so you need to talk about instead of the fertility, you need to talk about soil as a whole, not just NPK. And therefore, since soil is a living organism, right? It's a living system. And so you have to manage it as such and not as just a geological entity where you put in some fertilizer and make some crops grow. So the physical, the hydrological, the chemical, the biological, though all of these are very important in improving the soil quality. And to me, and all of us know that the soil is the key in the transition to what we call the regenerative or natural farming or agroecological farming. And this is what we would say: a typical good healthy soil would have all these arthropods and nematodes and earthworms and a lot algae and bacteria. All of this would be thriving. And our studies show that when you revive all of this, your input requirement goes down dramatically, and your soil organic carbon goes up, your water retention improves. So everything changes once you make the soil from a dead soil to what I call the living soil. And how have we done this? So the first thing is the most difficult one. There are other ones, but this is the most difficult one. Is how do you get farmers to gradually replace their chemical with bio inputs? So what we've done is that in about thousands of villages, we've set up what we call farmers' field schools. And these field schools, we just discuss what's happening to agriculture, cost, economics, etc. And we introduce the basic principles of this new form of agriculture. In many areas, we find, and I'm sure that would be true of Pakistan, it would be true of all of Asia, is that traditionally, all these farmers 50 years ago, 70 years ago, were practicing the kind of agriculture which we are again now asking them to do, right? They were using compost, they were using traditional methods to grow crops, right? We got them into for higher yields, we got them into fertilizers, etc., high dosage. But now we are saying this has messed up the land, now get back. So we find many people willing to agree. We have methods, and we don't have the time here, but we have now perfected a methodology for getting farmers from what they have on their land to make their own bio inputs. So soil enhancers, which is in India, it's called Jivamrut. So it gives soil, it's Amrut for the soil, and it provides life. Then you have biopesticides and biocompost. And we help farmers a lot of that. The basic ingredients are something which they find on their farm itself or in their house. So whether it is neem leaves, or whether it is acacia leaves, or whether it is cow urine or manure. So you use, or chickpea flour, we use a mixture of this, buttermilk. All of this, we've now made it into a very scientific process by which they can make these products on their own. They apply it to their farms for small farmers, and that's more than enough. What we find is that many farmers don't have livestock. So we've promoted a large number of enterprises, women-led, and they are running what we call, and I think in Zulfi, when you saw in Africa, everybody was doing it on their own farm. But when you have large farm holdings also in Asia, then you need an enterprise because everybody can't do their own bio inputs. And therefore, what we've set up is a large number of enterprises of women and farmers who then make these bio input centers on a large scale. And then they sell it in the market. They package it as attractively as other uh, fertilizer bags and compost bags are done. So that's the way to do it. We provide also bioreagents. So farmers have a lot of agri-waste. Now there are very easily available bioreagents. You give them the bioreagent, they can make compost, and it's available in about a month's time. So they make their own compost very fast from agri-waste. We've now also piloting a lot of other bio inputs. So for example, I've just come back, and on the coastal area, we have a lot of seaweeds. So seaweed extract is proving to be, you've just finished trials, and we find it to be extremely useful as a very high level because it has very high ammonia availability. So very high quality nutrient is available at a very low cost because seaweed is fairly easily harvested on the coastlines of many of the areas we work in. And I'm sure that would be the case on the Sindh coast also, where seaweed is available, mangroves are available. So this is another option we have. So this is one part and a major part of that. I'll come to the numbers, but we've now got about 100,000 farmers who are using biopesticide on a large scale. We've got about 20 to 30,000 farmers using this soil enhancers and about biocompost. So that it's now reached a scale, and farmers are adapting it very easily. These enterprises we have set up are now all becoming viable and standing on their own feet. So it's becoming now a way of doing agriculture. It's a long road, it's a transition, but that's happening. And I think this is the most critical part of the work which we are doing in the transition to sustainable agriculture. There are other three parts. One is that you keep the soil covered. So what we do is through biomulching, somebody does plastic mulching, or through cover crops. We have done this, and we are finding huge advantages. Less water evaporation, soil temperature doesn't go high, and we reach temperatures of 45, 50 degrees in many areas. So the soil is protected from that high temperature. That then earthworms get fed from it, so microorganisms thrive even when there's no crop growing. It increases the organic matter and reduces erosion. We also try, and this is very difficult to tell a farmer that don't do tilling, it doesn't really work. But we say you reduce the number of tilling, don't do too much deep tilling. We are finding that farmers do agree, and when they do that, we find that the habitat of the earthworm remains intact, and therefore the soil remains very healthy and porous. And finally, we advise, and this is relatively easy. We talk about crop rotation or crop diversity. It's now farmers are agreeing because the risks of growing monocrops are now apparent to them. So the farmers do agree. And we find context-specific crops for that. Many of the times we promote our millets or legumes as a part of the crop rotation, which is also very good for nutrition. So this is also something then. So these are some of the practices we promote as a part of regenerative agriculture. We've got now results, and these are studies which are done after 2-3 years of what we call conservation agriculture versus non-conservation agriculture. And we are finding an increasing, and in 2 years, 3 years time, we are finding increasing organic carbon content. We require less watering. The input costs have come down. Productivity is actually increasing in crops like maize. So they are earning more. So these farmers are now really scaling up, and it's spreading on its own. So I've not put it up here. I'm sort of validating it. They've just come from a field where a farmer has used a soil enhancer for 4 years, and his organic carbon content has gone up from 4.46 to 0.89 in 4 years flat. No chemical fertilizer. He's just applied the soil enhancer consistently for 4 years, and his organic carbon content, productivity levels are already going up. So I think we are seeing already the evidence of this new type of approach towards regenerative agriculture. To summarize this, and I won't take too long, we've now overall got about 200,000 farming households who are practicing regenerative agriculture, roughly covering about 80,000 hectares of land all over in all these various contexts, much more so In some areas, the new areas of Maharashtra and Uttar Pradesh are less so, because Uttar Pradesh has, they are all on the rice wheat. They've been cultivating rice and wheat like for ages. So to get them out of that assured but comfortable and yet declining income farming practice is taking time. But there also we are seeing some excellent results coming up. We are also seeing, I'm not sure whether, so paddy rice cultivation, we've now, and we've sort of, I'll just discuss it here, is we have this method which you all must be aware of, which is called the system of rice intensification, which is called SRI. And in this method, and also for direct rice seeding, from a climate point of view, it's very good, because methane emissions come down by about 40% because of this. But more important, yields go up and seed rates and water requirement goes down. And in climate, because the water availability is becoming a challenge, this new method is increasingly be adopted by farmers. So I think this whole shift to this new approach of rice cultivation has become very, very useful. Cotton is a major crop, and we're doing a lot of work on cotton. And we are using organic cotton to some extent, fully certified organic cotton. And we're also looking at Better Cotton Initiative, which is it's a way of reducing the inputs for cotton. So largely regenerative agriculture is, as practice, is now sort of, I would say, is largely fairly established now. I'll come to how let's talk slightly about nutrition. And the one part which we have done as a part of regenerative agriculture is that we realized that most of our agriculture was focused on food plus cash income. So that's what the farmer was focused on. So some food and a lot of cash, that's how his agriculture system was designed. And we are now slowly getting them to a food plus cash plus nutrition. So we're not talking about only just cereal crops, but can you introduce nutritive crops? Can you introduce vegetables? Can you introduce millets? And to some extent, can you introduce legumes? And that's actually working now. And therefore, but we realize that just introducing crop is not enough. You have to have a value chain, you have to have processing, you have to have markets. So we are introducing markets for many millet products actually, and that's really increasing in India. In fact, what's happened in India is the demand for millet, because of this consumer what is called sensitivity to nutrition, has gone up so much that this season the millet prices have doubled. So in fact, now you can't buy millets in India, in Gujarat, because the demand is much higher than the supply. So now it's very good news for our farmers that now we are getting, this season, we are going to get lots of farmers to agree to grow millets, because the prices have just doubled in the market, right? So I think this is a very good trend. Major biscuit companies in India, 4 of the major biscuit companies have all stopped the wheat biscuits totally, and they moved totally to multigrain or millet-based biscuits. So normal, urban consumers are also now getting it. We have a whole group which makes millet-based vegan, what we call sweets and cookies, and their sales have been doubling every year. So there is now, post-COVID, health has become important, healthy food has become important, and millet fits into that. Millet and non-pesticide crops are fitting into this new consumer awareness about healthy food, and therefore we are trying to cash into that by incentivizing farmers to go into this space also. So I think that's, in a way, we are in a positive loop right now as far as this transition is concerned. I'll then the other thing which I have spoken about earlier, which is about the nutrition garden, which is there for a lot of women who do not have access to vegetables for nutrition. So we are doing this, promoting enterprise nurseries, and we're also promoting entrepreneurs who make laddus out of this and serve it to children. And that is with moringa leaves and gram flour and jaggery, etc., and a lot with millets also. This is now having a huge market. This is becoming enterprise. In fact, I was just last week in UP, and now it's reached the common shops. So, the laddu wala is now keeping millet laddus also. Instead of those very sweet laddus we used to have of jaggery, now this is also changing. Yeah. Well, let me talk about the largely policy environment, and then I will not, I mean, if I'll
1 minute.
Just 1 minute, yeah. So let me just finish here. I will not go elsewhere into the other issues. So what is happening to the enabling environment in India, and why is it that our work is now being able to scale up so rapidly in the last couple of years? Is two areas. So let me first talk about the government. So the Prime Minister about 3 years ago made a larger announcement in the agriculture conference that they believe that the future for agriculture in India is natural farming, and the dependency on fertilizer and pesticides is not a healthy way to grow agriculture. So it's come from that. And I mean, and the government has taken it up. And after that, they've announced a natural farming policy as a part of the agriculture policy. They put some budget, not very large, but some budget in the national budget. There is money for natural farming. And state governments are now very, very proactive. So let's say the states I work in, or we work in, there are now subsidies for bio inputs. So or if you want to set up a bio input center, then the government will give you a subsidy. If you are not keeping cattle because you can't afford the fodder, then the government will pay you money to buy fodder for the first 1 year so that you have cattle and then you have manure and then you can make your own bio input. So there's lots of some good, some not so great, but subsidies coming into by the government to promote this natural farm. The agriculture research colleges and research agencies have been all asked to look at this phenomenon and not only focus on fertilizer related growth or pesticide related trials. So that whole the shift in the research agenda in all agriculture colleges is happening, including Pantnagar and the major colleges of this country. In Gujarat, for example, a new university has been started, which is called the Gujarat Organic and Natural Farming University, which is dedicated only to natural farming and research and trials and training on that. And both AKD and agencies are both trainers, and we work at the curriculum content. Civil society, of course, it was started, all this movement started from civil society. There were very individual farmers who were doing, they were model farmers all over in India. So they were the inspiration for the rest of us and also for the government. And now there are large CSO networks, and many of them we heard them in Dubai at COP28 who were making presentations. So there are these networks are on a very large scale promoting national farming, And one ex-IAS officer, Mr. Vijay Kumar, he has converted his entire state, Andhra Pradesh, into a natural farming state with huge state resources given to this. So I think this is where we are. I'll stop here. Yeah.
Thank you so much, Purva. I'm sure this will generate a lot of questions and comments. But let's move on, since we are now running a little bit behind, and it's my great pleasure to introduce Dr. Eric Boy. Eric is no stranger to the world of global nutrition. He's a driving force at Harvard Plus since its inception in 2008. And he's been known for his impactful leadership, including pioneering micronutrient research in various organizations, including Nutrition International. He is currently leading Harvest Plus Nutrition Unit. He oversees diverse research activities from biomarkers development to nutrition retention in biofortified crops, and collaborates strategically with organizations like the World Health Organization, Micronutrient Forum, and others. Today, we are very grateful that he's joined us, and I was sorry to learn, Eric, that you're just recovering. I had no idea, but you are going to speak to us on biofortification and the enhancement of nutrient content in crops. Floor is yours.
Thank you, Zulfi.
Can we put this on full screen? Eric, you may want to put this on full screen.
Okay, yeah, that's what I have.
It's in presentation mode.
Okay.
Yeah, great.
Yeah, okay. Well, thank you for the invitation, Zulfi, Jay, and Syed. It's really a privilege to be able to share some of the journey that biofortification has had during the past 30 years. We should get started by saying that the type of biofortification that I will be focusing on is conventional selective plant breeding, not genetic modification or genetic editing. the type of biofortification that focuses on iron, provitamin A, carotenoid, targets the poor rural farming populations, and is a cost-effective initiative because the upfront investment in research is mostly paid by donors, and then the public goods that come out of the crop system, international, are provided to the farmers as seeds or planting materials at no additional cost. And as you can see on the graph on the right, all the dark green bars correspond to a selective biofortification of crops, and it's way below the threshold of the World Bank as a cost-effective intervention to tackle hidden hunger. Well, the whole story of biofortification began in the 1990s with, believe it or not, with an economist asking the question as to whether the plants themselves could be allowed to do the work of loading up nutrients than big pharma adding nutrients to the food, etc. And after Dr. Bowie was able to convince plant breeders who were at the beginning the resistance force against biofortification, convince some key plant breeders that the nutrients could be enhanced without penalty yield on the staple crops. Then the journey really began, and it's been a 20-year journey since the initial funding in 2003. The program went through a discovery phase in which the breeding targets for the nutrients were established through dialogue between plant breeders and nutritionists. The germplasm that all of the CGI-R centers had was screened for higher nutrient lines, and that followed by the development of the first wave or the first generation of biofortified crops with at least 50% of the full target for each of the nutrients. The plans for nutritional research were developed and starting to being implemented, and starting around 2013, country teams that are made up of multidisciplinary groups with economists, marketing specialists, agronomists, plant breeders, and program managers and nutritionists. These multidisciplinary teams, through connections and advocacy in countries, were able to create enabling environments at the policy level and through many partnerships with the public, private sector, and civil society, so that biofortification through conventional plant breeding is now at its rapid scale-up phase, which I will go on to describe, very briefly, because each country has its own story. Each country had to develop its own strategies and partnerships to be able to scale up. But 30 years later, after Howdy had his first idea, this is what we have. Over 300 different biofortified varieties have been released in over 30 countries, and many more varieties or lines of biofortified crops are in the pipeline. And one myth about biofortified crops is that they only contain more nutrients, but that they might not be resistant to pest or drought, or to, in the case of rice, to submergence, etc. But the total opposite is true. All of the biofortified crops, or any of the crop or varieties, in order to be released, they have to meet a certain level of micronutrients on top of the average baseline level, and also have no penalties on yield. And so they must be, in the case of pearl millet, mildew resistant, high yielding and drought tolerant. In the case of high zinc maize, drought resistance, and some of the varieties are early maturing, etc. So no yield penalties is a must-have characteristic for any of the biofortified crop varieties that are released. And not only do we have over 300 varieties available to farmers, but the reach so far, as measured in the areas where the seeds are being deployed in 13 countries, shows us that about 100 million people are benefiting from these more nutritious crops, and not only one, at least one. Sometimes they have 2 or even 3 of the crops, and this is projected to increase. As you can see, the colored lines are projections. The orange part of the line is the conservative or the average projection, which defines the number of people reached by the end of 2023 at 100 million. And of course, we think that this is it is possible to continue in a curve with this type of decline or incline, and reach 1 billion people by 2030, 2040, if things continue as they have been. So how did we get there? I mean, how did we get, or how did the world get to so many varieties and so many people benefiting, despite having started the journey, against the current, so to speak? Well, first of all, the advocacy that has been key to getting an enabling policy environment in all of the countries where we work has been supported by peer-reviewed nutrition evidence that basically says that when people consume these crops regularly under controlled or uncontrolled conditions, that is efficacy or effectiveness conditions, there is a measurable impact on human nutrition. And the vitamin A crops have all been tested: maize, orange sweet potato, and cassava. And the results of the randomized clinical trials with these crops have all been pretty consistent in increasing the level of vitamin A, provitamin A intake. In the case of maize in Zambia, improving night vision in children, and decreasing the prevalence of low retinol in breast milk. And in the case of Kenya and Nigeria children, serum retinol has been modestly but significantly increased. And so provitamin A crops have proven to be effective, with the one caveat that maize, because of the long periods of storage, will experience carotenoid degradation over time. So by, let's say, 1 year of storage, the levels of provitamin A carotenoids are pretty low, and efforts in plant breeding and genetics should continue trying to get antioxidants in the same compartment as where the carotenoids are. Iron biofortified crops are common beans and pearl millet. Efficacy trials have been conducted with beans in university women in Rwanda, school children in Mexico, and also in India. And one effectiveness trial was conducted with black beans in Guatemala, in the eastern dry plains of that country. For pearl millet, there has been an efficacy trial conducted in Maharashtra with school children. There was no beans trial in India. This was the pearl millet trial in Maharashtra, and there was school children, and another feeding trial in the slums of Mumbai with children under 3, which is a very special group with very small gastric capacity, and we thought there was not going to be an impact when we started doing biofortification. In summary, the results for the efficacy trials with iron beans and pearl millet in the 2 countries that I mentioned are very consistent. Iron status improved after 5 or 6 months. That was the longest that the subjects were fed with these foods ad libitum. So iron status improved by iron status indicators like serum ferritin and total body iron. In the case of Rwanda, hemoglobin increased as well, but not in Indian school children because of the very fast growth rate. but also cognitive performance, and particularly the speed and efficiency of memory and attention functions improved in both groups of study subjects. In India, we saw an additional cognitive improvement, which is perception abilities done with standardized tests by Oklahoma State University. Behavioral performance, that is, that cognitive performance, was also matched by measurable changes in brain activity. So we have the whole mechanistic chain of events demonstrating that these crops improve iron status, and iron status, once improved, also betters the cognitive performance and the physical activity and work efficiency of subjects. So that's a win-win-win to follow Dr. Oza's win-lose-win example, because you have children or students that are cognitively better prepared and physically also better fit to carry on daily productive activities. And Julia Finkelstein did a meta-analysis of those iron studies that I just described, and the results showed that the iron crops do confer a significant protective effect against iron deficiency. The zinc crops are a little trickier because we don't have a very, very sensitive and specific biomarker that responds to dietary interventions with zinc. However, when we look at how much zinc is absorbed from the biofortified rice, wheat, and maize, the results are very consistent in that, well, intake obviously is greater from the biofortified varieties, but also the absorption, because of that higher absolute amount of zinc in the crop, is also higher. In the most recent study in children under 3 in Bangladesh, the difference in absorbed zinc was 300 micrograms, which in and of itself is close to 30 to 50% of the daily requirement of zinc for that age group. And if you count all of the zinc in the rice, the zinc added by biofortification and the zinc that was already there in the background material, you're really providing almost the full daily requirement to children of that age in Bangladesh. Similar results were found with maize in Zambia, with Dr. Hambich, Michael Hambich, may he rest in peace, found 4 years ago. And when we use that information on absorption to design and carry out zinc efficacy trials and effectiveness trials with zinc crops, we find that of the 3 efficacy trials done in India and Pakistan, and the 1 small effectiveness trial done in Pakistan, there was no change in plasma zinc concentration in any of those studies. However, in the largest study done in the surrounding areas of New Delhi, with 3,000 households, the group consuming high zinc wheat experienced, both the mothers and the children, less days sick, with, in the case of children, vomiting and pneumonia, and in the case of mothers, with conditions accompanied by fever. So zinc in this case seems to be conferring women more time for productive activities or for child caring activities, and children less time spending nutrients and energy defending against common disease. In Bangladesh, the rice efficacy trial that was conducted by ETH from Zurich with children under 5 demonstrated that, under 3, sorry, demonstrated that plasma zinc didn't change again. Microbiome metabolites and other indicators didn't change, but there was a time times treatment interaction in favor of the zinc rice varieties. And so the children at the end of the 9 months of intervention were a little bit taller for their age, the ones that consume high zinc rice. So that is basically the original research plan for biofortified crops, a single crop with a single nutrient being added through selective plant breeding. But from those studies, more hypotheses have emerged, like the list you see here. And I would just briefly touch on the relationship between zinc and non-communicable diseases, specifically the risk of diabetes, meaning high fasting blood glucose. And the study, systematic review conducted on the relationship between zinc deficiency and fasting blood glucose measured in disability-adjusted life years is very shocking. If you look at the beginning and end of that blue arrow, that is the attributable portion of DALYs that are caused by zinc deficiency. The 260,000 DALYs are caused by zinc deficiency related to diarrhea, and the attributable fraction of fasting blood glucose, high blood glucose, 8 million, is also due to zinc deficiency. So a disease that has never before been taken into consideration as being caused by a zinc deficiency, pre-diabetes or diabetes, actually causes more negative impact than diarrhea, which is basically the only morbidity that is now being used to measure the impact of zinc deficiency in children. So it's a 30-fold greater impact through the diabetes pathway than through the diarrhea pathway. And this varies by region and by country. The highest attributable fraction of high fasting glucose in countries was found in the Pacific Islands like American Samoa and Fiji, and in regions like, even in high income region. So this is something to look forward to in a trial that Dr. Bhuta and Dr. Jay Das's team are conducting in Pakistan as we speak. So in South Asia, scaling of biofortification has really taken up. And the reason for that being so is that teams there made up of national authorities, our own national staff, private sector, seed companies, etc., throughout the whole supply chain have been involved in promoting, multiplying, and retailing these biofortified crops. And in summary, for the South Asia region, which means Bangladesh, Pakistan, and India, over 80 varieties of biofortified crops have been released, and that is sweet potato, lentils, pearl millet, wheat, and rice, with the majority of varieties concentrating on wheat and rice. And as you can see, the blue lines are the thousands, millions of people already producing and consuming biofortified rice in Bangladesh. But starting 2017, the yellow and the orange lines, which are Pakistan and India zinc wheat, have been increasing steadily. And at the end of last year, it was estimated that in Pakistan, a high-yielding, moderately high zinc variety has taken up to 12% of the arable land that is cultivated with wheat already. And so impressive results from those three countries in South Asia. Nearly 40 million people already consuming by the end of 2022, any of those crops that I mentioned. Many farmers are having a surplus because of the high yield and are selling in Bangladesh 50% and in Pakistan almost 60% of their crops. So that means more income for farmers and improved livelihoods if they spend the money wisely, of course. And to wrap up and summarize, in order to create an enabling environment in countries for any agricultural technology to be scaled up, we need to work in all four fronts, enabling the initiative with strong evidence base, looking at the supply side as well as the demand side, and the enabling environment, which is critical in order to have the product when and where it's needed. And so the nutritional evidence is pretty strong or solid enough for advocating for further expansion of biofortification. A supply chain approach is really necessary to scale up effectively, and zinc deficiency, as we saw, is contributing to the double burden of disease through diarrhea and potentially diabetes in those countries and around the world. And I thank you very much.
Thank you very much, Eric, for this wonderful review. We will have questions at the end, but I want to remind people, over 100 people who are participating, to please put your questions in the Q&A. We will not be taking any questions directly of participants or from chat. And I see there are a number of comments there that people would like to maybe convert it into questions and put them in the Q&A formally. Abbas will share the link with the Q&A. So let's move on to our final speaker, who, as I had mentioned, is Dr. Emmanuel Saleh. Emmanuel Saleh is an assistant professor and director of research at the Aga Khan University's Arusha Climate and Environmental Center in Tanzania. He has undertaken exceptional work in agrarian studies. He holds a PhD in land and agrarian studies and a master's in public policy. And he has been a doctoral student fellow at Harvard and the Council for the Development of Social Science Research in Africa. His research interests and expertise span climate change, sustainable agriculture, and policy analysis. We are privileged to have him here, and he's going to talk to us today about the experience of a living environmental lab in Arusha. So, Emmanuel, the floor is yours. Welcome.
Thank you, Zulfi. Dear participants, it's a real pleasure to talk to you and really explore this experience of what we call a living environmental laboratory, particularly given that Zulfi Bhutta has really advanced these ideas of nutrition and sustainable agriculture through his Institute for Global Health and Development. So we in Arusha, Tanzania, are calling ourselves a new sister organization that is joining this important activity. Looks like okay. My slides are working, so thanks. But before I dive deep into what we do in Arusha, I wanted to bring to light, like, why are we interested in adapting the concept of living laboratory in Arusha, particularly within Aga Khan University? We all know that Aga Khan University, as part of the wider AKDN network, and thanks, Apurva, for discussing a lot about what you do within the AKDN network, is that AKU understand the need to engage communities. So by definition, a living laboratory is really a user-centered open innovation ecosystem, which is really based on systematic user co-creation approach, integrating research and innovation processes into real-life communities. And this is a definition that I think is much more broadly used, and it was advanced by the European Network of Living Laboratories, an umbrella organization of living labs around the world. The real idea is that every living laboratory is really specific to real context. So context specificities is at the heart of any living laboratory, because you want to engage the community, you want to engage community to get their desired development and their priorities in their attempt to improve their livelihoods. And therefore, in any living laboratory settings, whether it's a university campus, as it is for Aga Khan University campus in Arusha, or any landscape, also as we have a big landscape that we are using as a living laboratory, is to set that environment for people to come to learn and cross-fertilize ideas and come up with research priorities for having an impact on their innovation, on their experimentation, and moreover, to really have a policy impact. Therefore, we take this seriously and we prioritize people's needs. And as I will explain, most of our research plans and programs in Arusha are based on the needs assessment that we carried out by talking to farmers, talking to pastoralists, and talking to innovators who are working in the agricultural value chain. So to bring you to a real example of what we call a living laboratory, Aga Khan University in March 2022 established a center which we call Arusha Climate and Environmental Research Center. And it really resembles the picture you see on the right. We have a community outreach center building, we have demonstration plots, we have tree nursery, we have vegetable nursery. Both students and people are welcome every day or every Friday to come to learn in our land and our demonstration plots. And every year we have an annual gathering, we call it Farmers' Day, where all people in the agricultural stakeholder do exhibition from the government research institution in livestock, in farming, in seed. They all come and we learn, and I will show you some examples. So the university set out this center for at least 3 key goals. One is to designate this area, which is really high in ecological importance, for people to learn and to drive research and innovation in sustainability and environmentalism through a living laboratory, which I just described above. And most of our research currently focuses on climate change, environmental study, ecology, water, and renewable energy. And the idea is to solve the crises that our communities have. One quick example in terms of water. Arusha region, which is one of the tourist destinations, the largest in Tanzania, is facing a serious fluoride crisis within water that actually turns teeth to be black or red. And currently, with the impacts of climate change, either we face floods as it is now with El Nino, or droughts like as it was in the past 2 years. So setting a center in this landscape provides an opportunity for researchers to deal into this problem and provide solutions to communities' issues. So this center is set from the beginning to be really interdisciplinary, integrated within communities. And in our research design, we engage local citizens in many ways, and mostly as citizen scientists, to help us collect data and monitor research studies that we are prioritizing using indigenous knowledge, and also tapping into their understanding of what is a healthy and resilient grasslands restoration techniques. We are also really tapping into the indigenous knowledge of local communities in our neighborhood to understand what are the best tree species and those trees' importance in terms of our attempts to restore rangeland within the land that we own, and also support communities around our campus. But also communities have been very helpful in helping us understand and do studies on pollinators population. These are bees, from honeybees to Stiglitz bees. So in nutshell, the center that the university set up in Arusha welcomes partnering scientists from different universities and research institutions, given that we know from the beginning that Aga Khan University has a strong footings and expertise in health and medicine, but not much in climate change and environment. So our strength is in working as we build our workforce within, but to start with the local partners in Tanzania, that is research institutions, universities, and international universities. So in that case, we have signed strong MOUs with international universities such as Simon Fraser University, which is a comprehensive #1 university in Canada, and the University of Cologne in Germany. And in Tanzania, we just recently signed with top universities such as University of Dar es Salaam, Sokoine, and Nelson Mandela African Institution of Science and Technology. So we want to also engage with universities to bring their students who are interested to do field studies and summer school. And we just completed one or what we call our inaugural field school with a student from Simon Fraser University. And in September, we also had a large summer school group from the universities in Tanzania, Germany, Canada, US, and Cameroon. So the initial thinking of really looking at establishing the living laboratory and environment is due to the fact that our world is facing twin challenges of climate change and biodiversity loss. And you cannot address one issue of climate change, leaving the issue of biodiversity. You have to address these challenges at a go because the impacts are devastating. The reality that science is already settled about the significant climate change impacts on both biodiversity and environment at large brings us to really establish this center and set us our research against agenda around these issues. And what we also really bring as a new addition to climate knowledge and everything is the realities that we face in our own land at Aga Khan campus, that land use changes exacerbate the impact of climate change on biodiversity and environment. Given that wherever you cut trees, where there's empty land, where there's land that is hit by long-term droughts, then floods hit hard and infrastructure is destroyed. But more importantly, what we also appreciate is that failure to appreciate, adopt, and integrate local and indigenous knowledge in preserving environment is part of the reasons our planet is devastated by climate change. On the right, you can clearly see from the climate change report of 2022 that Africa is highly facing the impacts of human and natural climate impacts is widespread more because of human-induced, or in other words, human-caused climate change. So our actions, being it unsustainable farming, cutting trees, is part of the problem. So addressing these issues is just at the heart of this living laboratory in Arusha. So learning from the experiences of our farmers and responding to their priorities, Aga Khan University set aside demonstration fields. On the left, you can see there's a large tract of land set aside for growing vegetable, food crops, cash crops like maize. You can see a sugarcane as a windbreaker and trees on the far. But what is important, as I said, our demonstration fields are also used as a site for exhibition. So up there, you can see people in their tents demonstrating how to use the bee-resistant cloths, seedlings, particularly organic seedlings that are protected by the Tanzania Plant Health and Pesticide Authority. So a lot is happening on the ground. And given that we not only restoring our landscape that we have, we are also providing seedlings to our neighboring communities, to the district authorities, so that they can use to recover and restore degraded lands in the northern part of Tanzania. So we have large nursery where we provide seedlings for free to communities and schools. And the priority seedlings are for fruits that are nutritious and healthy, such as avocado, but also indigenous species, mostly yellow acacia, which is indigenous to this landscape and also more resistant to climate shocks. And after having established the nursery and planted over 1 million, nearly 1 million trees in our landscape, we also have Arboretum, which is so big and so huge and very good learning space for both interns, field school students, and summer school and visiting researchers. So as you can see, this is a huge landscape. Aga Khan University occupies around nearly 4,000 acres in Arusha, in a very prime land. And all this land has not only been reforested, but is sustainably farmed. So there's a lot of farmland here for coffee plantation, flower seeds that are exported to Europe. And in other parts, we even have horticulture that is also exported to Europe. So all the activities that we are testing in our research center have also been tested before when the land was acquired and utilized for commercial purposes. But to really understand the environment in details and agriculture and agricultural sustainability, there are bits that we are really looking in details. For example, many people are talking about the impact of pesticides, particularly industrial pesticides, but more so is the impacts of pesticides on pollinators, for example, bees and even honeybees. So Aga Khan University commissioned a rapid pollinators assessment in our land, given that most of the studies on pollinators are largely done in North America and Europe. So in Africa, you can literally find very little studies. And of importance that I just want to highlight is that in the sites that we picked different locations, particularly where we have a monoculture, that's where we plant coffee, but of real importance is a blue site where there's a mixed forest. And I just want to highlight that it is the mixed forest, particularly indigenous forest, which has the highest number of pollinators. And the reasons are many, but two important one is that mixed forest provides natural habitat, safe habitat, but moreover, the mixed forest provides flowers almost throughout the year. So bees have their shelters, have their food, they don't have to move. But if it's on a monoculture, particularly grevillea and coffee, then pollinators can only find particularly few flowers once in a year. So they cannot have it there. They will be very rarely found. But as I mentioned, pollinators are central. So we are, for example, now doing a large study now after a rapid assessment within our land to really work with our farmers nearby so that they can understand the role of bees in pollination and in enhancing sustainable agriculture and livelihood. So Aga Khan Foundation, Aga Khan University particularly help us to engage other actors within the pollination industry. That is a Tanzania Wildlife Research Institute, which is based here in Arusha. We signed an MOU with them, so they have a high-level entomology laboratory, and then there's a private company called Just Bee. We funded them to put honeybees, and that they are now collecting data for that. But as also Apuva mentioned, I won't go into details, to help our communities understand the importance of soil and land health, we just carried out large soil and land health assessment done by World Agroforestry and invited communities and students to learn on the basis of doing health assessment and why it's so important. And our data will be contributed to the global database on soil. And through these capacity building, we believe that communities can really understand, because it is through understanding the soil, you can really know what you're going to plant. But
1 minute, Emmanuel.
But it's really important to really go through the details of climate change and how it's really affects, because in the world, it's very clear, countries like Tanzania, which is rainfall, with the climate change, not only the productivity will be reduced, but the nutrients of the crops will be reduced. And it's important to look at on the aspects of livestock. Where there's a lot of droughts, there will be no grass. So that means not only the livestock will be losing quantity of milk and meat, but even the nutrients that the kids, for example, get from both meat and milk. One thing that we also want to do very seriously in Arusha is the transmission of indigenous knowledge in terms of land use management and knowledge from elders to the youth. So to wind up, this is so important for us. What we realize is that living laboratory is really an opportunity or a space where you can have inclusive anti-colonial environment where you put these understanding of climate and environment in practice. It enables not only cross-fertilization of ideas with communities, but put in practice the two eyes seeing framework where you use the indigenous knowledge and both more and modern knowledge to combine their strength and analyze the critical things that we understand within climate and environmental issues, such as climate change impacts. But having set a campus land as a living laboratory, you are allowing community to have this continuous learning and also allow researchers to interact with communities and the community of practitioners. And in that case, you're able to have a significant influence on policy and decision-making processes at all levels because you have communities at the grassroots level, researchers at the research institution level, and policymakers at national levels. So with that, I thank you for the opportunity and thanks for listening. Over to you.
Thank you very much, Emmanuel. And we have a whole bunch of questions, but what I will do is I will ask them in the order of the speakers and club a couple of questions. I request the speakers to be succinct so that we have time enough for hearing our worthy chief guest. So the first question is to you, Apurva, around asking about post-harvest. It's a bit unrelated, but what can be done about post-harvest fortification of wheat? And is there any experience from India of combining the value of sustainable agriculture with other traditional things like fortification?
There has been no real combination because regenerative agriculture, wheat production is not on a very large scale as yet in India. But the fortification in the mill level, I think people will be and Harvest Plus will be there have been quite a lot of experiences in the country of fortification of wheat, and I think it's now reasonably, the reports I have seen at least is that it's working now reasonably well. The mills have been incentivized, so I think the fortification part has been working well. At least from what I know in India, it's been a good experience in working with mills on post-harvest fortification.
Great. So these two things can be combined also with ease.
I think as the area under regenerative wheat grows, I think this will happen.
So one question on this, Apurva, is it fair to assume right now that many of the strategies on sustainable agricultures have been much more focused on things like vegetables and other products rather than staple foods, staple crops?
No, actually, because in fact, see, it was the case earlier, but now if you go to the largest work on regenerative agriculture is happening in the Andhra Pradesh area, right? Which is primarily a rice area and rice, maize. So therefore, basic cereal crops are there. So there's a lot of work happening in those areas.
Okay.
Millets, rice, maize.
Thank you. Well, we have a bunch of questions for Eric, which I'm going to try and some of the other harvest a little bit. So, Eric, there are a number of questions related to biofortification, particularly in looking at its quality. I see that you have answered a number of questions, but on biofortification, what is the overall status of the evidence? Is there now sufficient evidence for us to move this into policy domain, or is there still the need for more research? And I'm particularly looking at human impacts.
Yes, thank you for the question. There is significant policies, a number of policies in place already, given the limited amount of evidence available. Each efficacy trial costs close to $1 million, and each effectiveness trial costs over $2 million. So there isn't the resources to do trials for every country and every population. So at least there is one, if not more, efficacy trial for each of the crops that I described. And with that amount of evidence, the African Union has decreed that biofortification be a part of African countries' food and nutrition programs. In India, for example, it was also decreed, I think, by the president the prime minister, that no pearl millet variety can be released without a minimum amount of iron in it. And so since that decree about 3 years ago or 4, pearl millet overall has increased its iron levels from a baseline of the 32 to around 40. So, and in Nigeria, there are at least 17 policy documents in support of expanding biofortification with several crops in the country. The same thing in DRC and other African countries. So with the evidence that has been published in peer-reviewed journals already for the 8 crops that were described, policy has already been put in place, and in some countries even implemented. So I know that there is always the need for more effectiveness trials, and I think the direction where research is going now is for actual impact evaluations, where nobody gets anything for free. The seeds are sold through the market, the farmers grow them, and over time you measure the impact on their nutritional status to see real life nutritional impact. And
Okay.
those
Correct.
studies can only be done by the implementing agency. Yeah. Thank you.
So, Manuel, a very quick question for you from someone who wants to ask about a toolkit to address SPS measures with respect to climate and food safety. Is that something that rings a bell?
Yes, thanks for raising that question. So we are working on developing, because as I said, center was only started in March. We are developing toolkits, both scientific, but also the hard measures, like how do you really track the impact? So there's already initiative to have even cohort of studies, because if you introduce perennial crops, for example, like vegetable, you are expecting that will improve the well-being of students and then improve their performance in school. So there will be a lot of statistical measures that we are putting in place. So watch the space, and we look forward to engaging.
So we will make the addresses and contacts of our worthy speakers available, because I know that there are other questions and people may want to follow up. To do that, please just write to Abbas Alamdar. It now gives me the greatest of pleasures to introduce our worthy chief guest and give him the floor to potentially give us an overall impression and what can Pakistan benefit from this. So Dr. Kausar Abdullah Malik is a distinguished fellow and now the current president, the incoming president of the Pakistan Academy of Sciences. He has had a tremendous career in biotechnology, genetic engineering, and life sciences. He is the caretaker federal minister, as I've said, in national food security and research. And his career has been marked by enormous scientific contributions to agriculture. He, in fact, founded the Institute for Research on in Nibji in Faisalabad, and ran it with great aplomb. He is currently also the vice chairman of the Punjab Agriculture, Food and Drug Authority and the chairman of the Pakistan Agriculture Research Council. I can go on forever, but his greatest attributes are that he is a scientist par excellence and a great supporter. I've been very proud of my friendship with Kausar for decades now. So Kausar, the floor is yours.
Thank you so much, Dr. Zulfikar. It's a pleasure to be here, and I enjoyed thoroughly, all the lectures, especially by Dr. Apurva Oza, Eric Boy, and Emmanuel Asala. These were all very, very informative, and I enjoyed it, and I thank you for giving me this opportunity, you see. I mean, all those things that have been talked about have been, my topic of research also, and my topic of lecturing to my students, you see. For example, we very emphatically say that soil is a living entity. I use it as a mantra, you see, that soil is a living entity. It is as living as human beings. So when you walk on soil, keep in mind that you are walking on a living entity, you see. So anyway, these are the facts, you see, and we have been working on it. And, all those things we used to call it a conservation agriculture at that time, which is now being called degenerative agriculture. But, it is virtually the same. And these are extremely important interventions as far as the soil health is concerned, you see. But we, from another point of view, we must keep that in mind that we have to look for the food security as well, you see, with these virtually 6 million more mouths every year, coming on this earth, it is very difficult, to have the generative agriculture and sustainable agriculture of that kind, you see, So we have to be very, very cognizant of the fact that we have to take care of the food requirements of the entire population, you see, and so by using the so-called the organic agriculture approaches, we may not be able to achieve that. But then we have to use all the technologies in order to maximize the input of all the sustainable agriculture aspects of it, you see, So this is extremely important, you see. But on the other hand, the kind of fertilizers that we use, kind of chemicals that we use, for example, for making urea, for example, any nitrogenous fertilizer, chemical fertilizer, we use, the temperatures that are used are 500 Celsius as a temperature and 200 atmosphere per pressure, you see. This is the kind of energy that goes into combining nitrogen with hydrogen, you see, so this is a tremendous energy input. And then when we talk of climate change and we don't think of these energy inputs going into all these chemicals, I think we will be alarmed to see the impact of all these. Anyway, these are some of the things for the researchers, and we keep on working on it and giving alternatives of or minimizing the use of these chemical fertilizers, you see. The other my area, and I was very, very interested, and I thank you, Dr. Eric Boy, for giving a very comprehensive lecture on biofortification. That area has also been for many years, and even now, an area of my interest and my research. My only observation or suggestion is that we somehow do not take into account all the bioavailability aspect of it. You see, all the micronutrients are normally there in a plant, but whether these are bioavailable for human consumption or not, you see, this is extremely important. And there we find that the presence of phytates is extremely important, and we had been working on screening many varieties for phytic acid content and to see the correlation of these phytic acid contents to bioavailability, you see. We have been, with the help of Harvest Plus, we have introduced two very important varieties as far as the zinc and iron is concerned. One is Zincol and the other is Akbar. And both these varieties are quite popular, but they are popular because of their high yield, you see. They are very high yielding varieties, and that's why these are popular. It is still to be seen whether these have any impact on the human nutrition or not, you see. So this is extremely important. The other very interesting development which is happening in the world is in the area of golden rice, you see. I mean, in Philippines and in Bangladesh, it is being introduced now in a massive, in a campaign form of, I mean, they are supplying all the seeds of golden rice to all the farmers and trying to get it cultivated, and it has a very strong government support as well. So this will be an interesting thing to see that what impact that has on vitamin A fortification, on their blindness in incidents and etc., things like that, you see. So these are very, very important areas, and we are extremely thankful to the organizers of this webinar to have highlighted all these areas, you see. So I'm once again want to thank Dr. Zulfikar Bhutta and his team for organizing this webinar, and we will be very happy to participate in any activity that is coming our way. And we hope that we continue our interaction in the future as well. Thank you so much.
Thank you so much, Kausar, and thank you so much, valuable, wonderful speakers, for your participation and contribution. This is part of our continued series of webinars from the Institute that we do regularly on various topics. And the next topic in early 2024 would be on our work on gender equality and science. And Abbas, let me pass the floor back to you to make some housekeeping announcements, particularly on giving people the information on our website. Here, thank you, everybody. Abbas.
Abbas, you're muted.
Thank you, Dr. Bhutta. And thanks to all our distinguished speakers and panelists for taking out the time to provide their input around this important topic. We are very grateful for all your efforts. I would like to tell all the other participants and attendees of this webinar that I've pasted the information regarding the link for the certificate, and also the link to our website will be posted shortly as well, where you can visit in the upcoming week for the video of this Zoom webinar. Once again, thank you for your participation, and we look forward to having you join us in 2024 for our next informative webinar.
Thank you.
Take care, everyone.
Thank you.
Thank you, Dr. Malik. Take care. Dr. Malik, you can leave, sir, whenever you want to. Please remember to fill out the form provided above if you wish to receive a certificate of attendance. We will only be providing the certificate to the individuals who have filled out the form. And again, in the upcoming week, we should have the Zoom webinar uploaded to our website. I have shared the link with you already. Please visit it in the end of the coming week to view the Zoom session recorded live. Thank you. If you have any questions that you feel that weren't answered, please email them to me. I have shared my email address above, but I will share it again. I will do my best to get you your responses from our speakers and panelists